So we just finished Unit 4 where we were using properties of exponents, writing expressions in exponent form as well as radical form. And now in Unit 5, we're going to be talking about the exponential function and then later on another parent function. But starting with the exponential parent function, y equals 2 to the x, it would be easy to figure out what the graph would look like as long as we would pick values for x and then figure out what the values for y would be. So let's go ahead and do that just to get an idea what the graph, why the shape of the graph is what it is. So if we raise 2 to the 0 power, we get 1. If we raise 2 to the first power, we get 2. 2 to the second power is 4, and 2 to the third power is 8, and so on. But let's take it a step further. Let's go to the left. Let's think, well, what would y be equal to if x were equal to negative 1? Well, 2 to the negative 1, we know that to be 1/2. 2 to the negative 2 is 1/4, 1 over 2 squared. 2 to the negative 3 is 1/8. So if we plotted all those points, 0, 1, 1, 2, 2, 4 would be up there, negative 1, 1/2, negative 2, 1/4, and if you notice here, as we get bigger in the negative direction, the y values would get smaller and smaller, but never equal 0. So actually, for the first time, we're going to get an asymptote. Well, we had asymptotes before, but for the first time, we're only going to have one asymptote. And in this case, this is what the graph would look like. After you hit this key point right here, that's the key point. Key point. We'll talk more about that as we get into transformations. But the idea here is once x gets past 0, the y values start climbing very quickly, a lot quicker than the x values. It's called exponential growth. You may have heard exponential growth before. Well, anyway, 2 can be raised to any power, so therefore the domain is all real numbers. Let's get the domain and range in there. And then the range would be the lowest y value to the highest y value. And just to make sure we're clear here, the x-axis is actually an asymptote, and so raising 2 to any power can never be equal to 0, and it can never be negative. And so we can get as close to 0 as we want, but we never actually hit 0. So the range then would be from 0 to infinity, not including 0, and moving all the way up as high as you want to go. We can also see that the y values as we move from left to right in the domain, from negative infinity to positive infinity, the y values are always getting bigger, so therefore the function is always increasing. The function is never decreasing if it's always increasing. Now the x-intercepts, as we said, the graph would never hit 0, and so therefore we have no x-intercepts on the parent function. However, the y-intercept, if we look here, we already found it. I'm not sure what I had just said. Sorry, I paused the video. One of the maintenance guys came in to do some work in my room. Anyway, back to y-intercept, we plugged in x equals 0, and we got y equals 1. So the y-intercept is 0, 1. Looking at a max, there is no max. It goes up forever. And you might think that 0 is the min. However, we defined the max and min to be whatever real number for the min. We'd have to find a real number that the function would be equal to, so a y value that the function would be equal to without going lower. Well, there is no lowest y value that the function has as a value. So in other words, 2 to the x can never be 0, although 0 is it's like a floor, but you can get as close to the floor as you want. So there is no lowest real number that we would call a minimum. So in other words, long story short here, there is no minimum value. And then horizontal and vertical asymptote, we already said that we do have a horizontal asymptote, and that has the equation y equals 0. It's the x-axis, and the equation again is y equals 0. There's no vertical asymptote. And then the end behavior, this is a new one for us. Getting stuck here with the paper. The end behavior, as x approaches infinity, as x approaches infinity, the y values also approach infinity. And as x approaches negative infinity, the y values approach 0. So, as I said, this is a new one for us because now we have, as x approaches negative infinity, y is approaching 0.